So today's webinar discussion will be an introduction to the Azure Service Fabric. The Service Fabric, the things that we'll go over in the webinar would be what exactly is the Azure Service Fabric. We'll go over a discussion of the two varying architectures in the monolithic and the microservices. Then how Azure Service Fabric fits into all of this, why one should use it. We'll look into what are the different options available for building microservices in Azure. We'll talk about the different types of microservices and then summarizing all the capabilities of the Azure Service Fabric, what it brings to the table. And lastly, we'll follow it up with a small walkthrough of a .NET application, which is being hosted in the Azure Service Fabric. So starting off, what is the Azure Service Fabric? Now, the Azure Service Fabric is a Microsoft's platform as a service for building and deploying highly scalable microservices-based cloud applications. It was born from Microsoft's many years of experience in delivering mission-critical cloud services. It's also common knowledge that Azure Service Fabric powers many of the Microsoft services today, including the SQL database, Azure Cosmos DB, Cortana, Microsoft's Power BI, Microsoft Intune, the Azure Event Hubs, the Azure IoT Hubs, Dynamics 365, Skype for Business, just to name a few. All in all, it's a distributed systems platform which makes it easy to package, deploy, and manage your scalable and reliable microservices and containers. Service Fabric also addresses the significant challenges in developing and managing cloud-native applications. Developers and administrators can avoid infrastructure problems and they can focus on implementing your mission-critical, demanding workloads that are scalable, reliable, and manageable. Service Fabric represents the next generation platform for building and managing these Tier 1 cloud scale applications. Moving on, to understand the essence of the Service Fabric, we will first need to understand the evolution of monolithic applications and how we have moved on to microservices based applications. Now, before microservices, most of the applications were built in a monolithic way. Now, in a monolithic architecture, the app's functionalities are tightly coupled into one service. This approach can, and it usually does mean, long downtimes when deploying new features, which results in fewer opportunities to make updates. Also, there are downsides when it comes to scaling, because every component scales at the same rate regardless of the use. Scaling monolithic apps to meet demand is slow and it's expensive. Availability and reliability are achieved by hardware redundancy, which means it incurs additional cost and complexity. Now, in a cloud era, it's a rather unproductive way of doing business. Now, today, the time to market, the availability, and the ability to scale on demand has become even more critical than ever. This has resulted in a shift towards building microservices-based applications. Now, the name microservice conveys the fact that the size of the service actually matters. Microservices are supposed to be small. Each application is split into a set of finely grained, loosely coupled services. Examples of such application can be, you can have your protocol gateways, you can have your user profiles, it could be shopping carts, it could be an inventory processing system, so on and so forth. Now, the benefit of decomposing an application into different, smaller services is that it makes the application easier to understand, easier to develop, and easier to test, which is great because these services can be independently updated and scaled, thereby improving the agility and the productivity. Now, even though these simplify a great deal, Microservices-based environments are sometimes more complex than their monolithic architectures. To make a microservice-based environment work, developers actually need to write additional code in areas like the inter-service communication or handling failures. Still, today's internet-scale services are built of microservices with just the right tools, keeping the service healthy and functioning. And Azure Service Fabric is one such tool. Next, we move on to why do we use the Azure Service Fabric? Now, the intent of Azure Service Fabric is to provide developers with a very rich platform that addresses many of the complexities that are associated with building cloud-based distributed applications, which run on a high density on a shared pool of machines. Now it's tailored to create cloud services which start off small, but then they grow to massive scale with hundreds or even thousands of machines. Service Fabric lets developers orchestrate their microservices. All they need to do is you need to tell your Service Fabric how many instances of a service you want to run, how much compute power and storage that you need. And the Service Fabric will take care of spinning up the virtual machines, launching the services, and so on. Where the Service Fabric truly excels is the automated lifecycle management that it offers. It can manage your software updates and watch over the health of the services throughout the process. Let's say you want to update a component of your application and have the Service Fabric roll that into production. Say a health check fails down the line, Azure Service Fabric will automatically roll back the application to a previous version. The Service Fabric enables microservices in a quick and efficient way. Service Fabric reliable services are powerful concepts, and they allow you to lift and shift your application, scale them, make them fault tolerant, disaster recovery, and resilient. But this is not the only option that is available for building microservices in Azure. So let's look at the three options which are available in Azure. Now the first one is the Azure Container Service. Microsoft's implementation of Azure of the open source container technologies based on Docker. It lets developers manage your underlying infrastructure, be it the virtual machine, be it the storage, the load balancer, and they're kept separate from your application. It offers developers three major container orchestrators which are available today: DCOS, Swarm, and Kubernetes. Now you can start with containerizing a monolith. It can then be gradually broken down into multiple smaller services. The process of breaking down a large monolith into smaller services is entirely in the control of an application developer or an architect. The Azure Container Service is primarily about the infrastructure and the orchestrators. Next, we have the Azure Service Fabric. The Azure Service Fabric allows you to focus on business objectives and not on the infrastructure. That's why it can run on any premise, on any cloud, be it AWS, be it Azure, be it any other cloud, open source cloud platform provider. Now, this is a great option for teams who are looking to build an application using microservices architecture on-premise. When the decision on whether to move to the cloud or not is finalized, they can simply port their application from on-prem into the cloud. Next, we have the Azure Functions. Now, as application architectures evolve and the microservices are decomposed further and further, they will be essentially reduced to a single function. Azure Functions are great in executing some logic either in response to a trigger or be run on a predefined schedule. Now, depending on your requirements, you can choose either one of these three services for building your microservice. Say if you're looking to deploy your application in an environment like Linux and you're comfortable with working with an orchestrator such as a Swarm or Kubernetes or DCOS, you would go for the Azure Container Service. A typical three-tier application, a web front end, a caching layer, and a database layer can easily be containerized using just one single Docker file. It can be continuously decomposed into smaller services gradually. If your application wants to have its state saved locally, then you would go for the Azure Service Fabric. It's also a good choice if you're looking to deploy application in a Windows server-based ecosystem. The biggest benefit is that your Service Fabric applications can run on-prem, they can run in Azure, or they can run in any other cloud platform as well. Lastly, if your application needs an HTTP endpoint for a potentially wrong running process and it doesn't have an elaborate programming model behind it, Azure Functions is a good option. If you're looking to get a simple application model and you don't want to get into the setting up or managing your underlying infrastructure, Azure Functions is your go-to option. Next, we'll talk about types of microservices. Now, Service Fabric enables you to build applications that consist of microservices or containers. Deciphering the number of options that you have and the type of service that you want to build. It can be complex and it depends on your scenario. Now, every application is composed of many services and each service likely has a different programming model. There are two main types of services. One is the stateless service and one is the stateful service. Moving on to the stateless service. Now, stateless services are a familiar paradigm in web development. You typically have a middle tier. It receives your request. It then calls out a database where your state is stored. When those requests to the data store are expensive, there is often a cache mechanism also in place. Now, since there is no state maintained inside the service, a request can be routed to any instance of the service. Typical use cases of a stateless application is, say, a web interface for end users, an API gateway to other services, so on and so forth. Now, it's important to note that a Service Fabric application will typically have a combination of stateless and stateful services. A stateful service is different from a stateless service in the fact that your data is stored on the same machine that the service is running. There is no external data store. It removes the need for additional layers like your caches, your queues, and thereby it simplifies the system and simplifies the service. The latency in the system drop is also low because your data can be retrieved without additional network calls to an external store. Now that the data is on the same machine as the service, if your machine fails, so we would lose all the data. But that is not the case with Service Fabric. The Service Fabric runtime manages the reliability of the state for you so that we do not have to worry about the machine failures. Typical use cases of stateful microservice-based applications are, say, at any data service. You have the inventory service, you have an ordering system. A lot of the gaming scenarios in today's world use stateful applications. Most of the services where data is stored externally and pulled into for processing and data analytics and workflows are examples of stateful microservices. Moving on, we will summarize some of the key capabilities of the Azure Service Fabric. The first one being Azure Service Fabric is neutral on infrastructure. It is available for deployment on-premise or in any cloud that you can imagine, be it Azure, be it AWS, be it OpenStack, be it VMware, anywhere. It's operating system neutral as well, so it supports Windows and Linux. Moving on, in addition to the stateless microservices, Azure Service Fabric also supports stateful microservices, where your compute and your data are co-located so that you reduce the latency and you can enhance the performance. The development environment in a software development kit, an SDK, is identical to your production environment. That means the exact same code that runs on your local development cluster will be deployed to the cluster in another environment. It provides you with the ideology of writing a code once but deploying it anywhere. Lastly, the Azure Service Fabric provides full application lifecycle management and CI/CD. An outstanding functionality of lifecycle management is your automated update rollout with health checking, with the option of automatically rolling back buggy updates. So let's wrap it up with a small demo walkthrough. Now in this demo, what I've done is I have created a sample voting application. Let me just open up. And basically it contains a web front-end service which is written in ASP.NET Core, and it also has a backend service written in ASP.NET Core. Now the front-end service, what it does is it serves the web page and it exposes the API for the backend service to communicate with. The backend service, it uses a reliable dictionary which is on disk, a classic example of the stateful service. So there are no databases involved for storing the application data. The flow of application is, let me just open the portal. So this is the basic web front end. And what I can do, it's a very simple voting example. I can put in and it will generate a list stating the number of votes. If I click on where it states 1 vote, if I click on it, it changes to 2. Now what is happening, the flow of the whole web front end is the JavaScript on the web page is sending a vote request to the web API as an HTTP put request. The web front end is then using a proxy and it's forwarding the put request to the backend service. The backend service is taking the incoming request and it's storing the data in a reliable dictionary, and you have it replicated across multiple nodes within the cluster and it's persisted on the disk. Now all of your data is stored in the cluster, so you don't need any database for it. I can just run you through. So basically the voting web is the front end for my application, and the votes controller is which is actually loading up the view. So if I go into the put method, here I am basically, here is where the proxy request is being generated and being sent as a put to the backend, and here it's waiting for the backend to respond back to the view. The voting data the Wood Data Controller, is where I actually create a reliable dictionary. So I create a state manager which gets or creates a reliable dictionary, and it's called counts. And all of your interactions with values in a reliable dictionary require a transaction. So here I'm creating a transaction, and we update the value of your relevant key and commit the operation. Once your commit is done, the data is returned in the dictionary and it's replicated across multiple nodes in the cluster. If a failure occurs, the backend service can fail over to other nodes since the data has been replicated, making it highly available. So this is just the simple demo application. Another thing, the Service Fabric Explorer, it runs in all of your Service Fabric clusters. So since this application web app has been deployed in my local cluster, it's running on localhost with a port that I have defined, 8080. The Service Fabric Explorer is accessible using the management HTTP management port, which is 19080, and it shows you the health of your application. It shows you the number of nodes on which your application is deployed and the services that it's running. So right now it's running two services. One is the web front end and one is the back end. You can see it in the drop down list over here. So I have the voting data, which is the back end, the voting web, which is the front end. The amazing thing about the Service Fabric Explorer is you can scale the service right from the drop down menu. So I can have multiple instances stated here itself. So I can have 3 instances of the web front end running in case something goes wrong and the system has to fail over to another node. So that's pretty much it on the demo and the webinar end. Thank you everyone for joining. I'll be handing it over back to Meghla.
Thanks, Aman. Do we have any questions for Aman? You could either type them in the chat window or you could speak up to Aman. Any questions at all? You can always reach out to us, and if you have any questions that you want to email it to, you could email amank@cloud9infosystems.com for more if you have any questions. So looks like there are no questions, so we will move on. And I would request all the attendees, if you could share your email addresses in the chat window. We will send you the recording and the deck of this presentation. We usually post our recordings and the decks on our website, so you could log into cloud9infosystems.com, and under our resources you should be able to find all our previous recordings and deck as well. About the assessment slide that you see on the screen, the Azure assessment is Microsoft and a Cloud9 joint investment, and this is a consulting service that is available for your organization, and depending on your organization it may be free, or you may use these consulting hours to get a roadmap of to one of the services mentioned, like the Azure migration, SQL upgrade, BI and analytics. So if you're interested, please email us at c9sales@cloud9infosystems.com, or you can call us at 855-225-6839, so that our sales department can help you with more information about the assessment. Thank you for joining us today. We will send out our communication for the next webinar very soon, probably in a couple of days, which will be on a different topic and a different presenter. So please join us for our future webinars as well. We look forward to seeing you in our next one too. Thank you, and like I mentioned, any questions, please feel free to reach out to us. Aman is available at amank@cloud9infosystems.com. You can direct the questions to him, and we will reach out back to you. Thank you, everyone. Have a very good afternoon. Thanks.
Thank you everyone for joining.